So, have you ever been deep into research on a core business strategy topic? Maybe deciding between a wholly owned subsidiary or a joint venture for market entry?
Oh, absolutely. And you find these two papers, both by really smart people, using seemingly good data.
Right. And they come to totally opposite conclusions, both
Or
statistically significant. It makes you wonder, how is that even
what
possible?
exactly? It feels like the data should point one way, but it's often not about a failure of the data itself. It highlights this fundamental issue in complex research.
Gotcha.
It's the huge impact of all the subjective choices a researcher has to make. Which variables to focus on, how you define performance, the exact time period. These choices can totally change the outcome.
Okay, and that's precisely what we're getting into today, isn't it? We're looking at sources covering this massive scientific project. It was kind of crowdsourced.
Yeah, that's a good way to put it. It's a meta-scientific study. They used what's called the many analysts approach, specifically in international business research, or IB.
And the goal.
Well, the mission was pretty ambitious for IB research. They took this one really rich, complex data set. It tracked Japanese firms' foreign subsidiaries over almost 2 decades, like 1991 to 2009.
Okay, quite a time frame.
Definitely. And they gave the same data set to 57 different independent expert analysts.
57 teams. Wow.
And they all had the exact same task: answer 4 specific open-ended research questions using this data.
So the stakes here feel pretty high, especially if you're making decisions based on research findings. This is like a real-world test of how much those researcher choices matter.
It really is. It shows how a finding might look solid in one paper, but could just be, an artifact of the particular path that one researcher took. We need to know what's truly robust.
Okay, let's really unpack this. Where do we start?
Well, the core idea is this concept researchers call the garden of forking paths. Basically, analysts have tons of what they call degrees of freedom when they build their statistical models.
Like deciding which control variables to include, how to measure success, what to do about missing data points, that kind of thing.
Exactly. Now, a lot of concern often focuses on p-hacking.
Right, where researchers maybe nudge the analysis just enough to get that result they want, like getting the p-value under 0.05. Strategic choices?
Precisely. That's strategic elasticity. But this study, it's focused more on something maybe even more common: inherent subjectivity,
Meaning?
meaning good faith differences. Competent ethical researchers looking at the same complex problem can simply make different, perfectly defensible analytical choices. It's not about cheating, it's just there are many reasonable ways to slice the data.
And this setup really put that to the test. You said 57 analysts.
Yep, 57 analysts or teams from 20 different countries. Most were actually experts in strategic management or international business, so these aren't novices.
Okay, top people, same data, same 4 questions.
Yeah.
What happened when they crunched the numbers?
Okay, this is where it gets really, really fascinating. The results were all over the place, just radical dispersion.
How so?
First off, no two analyst teams ended up using the exact same combination of variables, statistical method, and sample selection criteria. Every single team chose a unique analytical path.
57 experts, 57 unique recipes from the same ingredients. That alone is pretty striking.
It is. But then, the results themselves. For all 4 of the research questions they were given, different analysts came up with statistically significant results. P less than 0.05, but in opposite directions.
Wait, for every question. So Team A could publish a paper saying, we found a strong positive effect. And Team B, using the same base data, could publish saying, we found a strong negative effect.
That's exactly what happened. That's what the authors mean by radical effect size dispersion. It happened across the board.
That's huge.
Yeah.
That implies that a typical published study, the kind you might read and rely on, which usually presents just one analysis,
Yeah.
it could have easily, logically, reached the opposite conclusion if the researcher had just made different but still defensible choices along the way.
Yeah, precisely. The potential for contradiction seems almost built into the process when dealing with complex data and many choices.
So if we can't just trust one analysis, what do we do? How do researchers manage this uncertainty?
Right, so there are 2 main strategies discussed. The first is aggregation, basically. You average together all the different results to see if there's some kind of overall consensus, a collective signal.
Okay, find the average answer from the crowd.
And the second is parsing, trying to figure out why the results varied so much, like what specific choices led to different outcomes. But let's start with aggregation. They had almost 600 analyses in total across the 4 questions.
Okay, let's look at those questions. What was research question one? RQ1.
RQ1 was about that classic IB decision, the relationship between entry mode, so going in with a wholly owned subsidiary versus, say, a joint venture or acquisition, and how well that foreign subsidiary performs.
And theory points different ways on this one, right?
Yeah. It does. You've got transaction cost theory, which often leans towards sole ownership to minimize risks and maintain control. But then internationalization theory might suggest shared ownership, like JVs, can be better for learning or sharing risk, especially in new markets.
So, conflicting ideas going in. What did the aggregated result from the 57 analysts suggest?
When they averaged everything out for RQ1, there was a directional effect. It suggested that overall, wholly owning a subsidiary tends to lead to better performance, kind of siding with the control argument.
Okay, so an answer. But you sound hesitant.
Well, yes, because the sources are clear. This finding was statistically quite weak. The confidence interval around that average effect. It came really close to including zero. Meaning, by standard scientific conventions, you couldn't confidently rule out the possibility that there's actually no effect at all. So the aggravative answer is, at best, suggestive. It's not a slam dunk.
Right. So if you're that CEO making the call, the average advice is lean toward wholly owned, but it's advice built on pretty shaky statistical ground, according to this crowd.
Exactly. You'd want more than just that average.
Okay, let's move to RQ2. This one was about intangible assets, like brand or tech, and ownership levels.
Yes. What's the relationship between how much intangible stuff a firm has and the percentage of ownership they take in their foreign subsidiaries?
And here, theory is more aligned, I gather.
Much more. Internalization theory is pretty clear. If you have valuable proprietary knowledge or assets, you want higher ownership stakes to protect them, to stop them leaking out to partners. There's strong theoretical consensus.
So did the crowd's results back this up?
They did, quite strongly. The aggregated result was pretty clear. Greater levels of intangible assets are associated with parent firms taking higher percentages of equity ownership.
So this one held up.
It really did. This was the one finding that seemed robust across the huge variation in methods. It shows that aggregation can work and reveal a strong consensus when the underlying effect is powerful enough. Meaningful claims are possible.
Okay, so one clear result from aggregation. What about the others? RQ3 was about policy uncertainty.
Right. The relationship between policy uncertainty in the host country, think political instability, changing regulations, and the firm's ownership level.
Find the results.
Inconclusive. The aggregated results showed no clear directional effect, which, frankly, mirrors the ongoing debate in the literature.
How so?
Well, when faced with uncertainty, some theories suggest firms might want partners to share the risk, leading to lower ownership. Others suggest you want full control to react quickly and avoid partner problems, leading to higher ownership. The data collectively didn't choose a side.
So the ambiguity in the real world was reflected in the ambiguous aggregate result. Makes sense.
It does. And then the last one, RQ4, was even more complex. It looked at policy uncertainty as a moderator.
Meaning, does policy uncertainty change that relationship we saw in RQ2? The
Yeah.
one between intangible assets and ownership.
Exactly. Does high uncertainty make firms with lots of intangibles take even higher ownership or maybe lower? Again, no clear aggregate evidence emerged. Finding reliable moderation effects is notoriously difficult, especially when analysts have so much flexibility in how they model things. The signal just got lost in the noise, apparently.
Okay, so aggregation gave us one solid answer, one suggestive one, and two inconclusive ones. Not exactly a crystal clear picture from just averaging.
No, it highlights the limits of just averaging when there's so much underlying variation.
Which brings us to the other approach, parsing. Trying to figure out why the results were so different. Can we explain the variance?
Yes, and this is where it gets quite revealing about what really drives results in these complex data sets.
What did they find?
They found that the specific way analysts operationalized their variables, how they chose to measure the concepts, accounted for a huge chunk of the variance in results.
Yeah.
Much more than other factors.
How much?
For RQ1, the entry mode question, the choice of independent variable, or the specific pairing of phi v and dependent variable dv, explained almost 74% of the variation in findings. For RQ2, the intangibles question, it was over 51%.
Wait, more than half the difference in results came down to just how they measured things like performance or intangible assets, more than, say, the fancy statistical technique they used.
Pretty much. It suggests these low-level specific measurement choices are incredibly consequential, maybe more so than the broader modeling strategy.
Can you give an example?
Sure, remember RQ2, the intangibles and ownership question? The aggregate result was strong, but there was still variance.
Right.
Well, they found that when they zoomed in on the subset of analysts who specifically used equity share percentage as the measure for ownership, the BV, and specifically used advertising expenses as the proxy for intangible assets, the IV.
Okay, very precise combo.
Very precise. For that specific combination, nearly all those analysts reported results that were either pointing in the same direction positive or were very close to zero. The radical dispersion disappeared for that narrow slice.
So forcing that level of specific agreement on the measurement essentially forced agreement on the outcome. It reduced that garden of forking paths.
Exactly. It drastically cut down the analytical wiggle room, leading to convergence.
Okay, that makes a lot of sense.
Yeah.
Now, what about the researchers themselves? Did the expertise of the analysts play a role?
It did, but perhaps not in the way you might expect. They found that analysts who were identified as having topic expertise specialists in strategic management, or IB, were statistically more likely to find larger positive effect sizes across the questions.
Larger positive effects.
Huh.
How do we interpret that? Is it that experts are better at finding the true positive relationship, or are they maybe more susceptible to seeing what the dominant theories predict? Kind of a confirmation bias.
That's the tricky interpretation, isn't it? The study can't definitively say why. However, they did another crucial check.
What was that?
They reran the main variability analysis, looking only at the results from the experts.
Did the radical dispersion go away when only looking at experts?
No, that's the key point. Even among just the experts, the qualitative conclusion was the same. High variability, with statistically significant results pointing in opposite directions for all 4 questions.
So expertise might slightly nudge the average effect size, but it doesn't solve the fundamental problem of subjective choices leading to wildly different outcomes.
Exactly. The dispersion seems inherent to the task, not just due to including less experienced analysts.
This brings up that confirmation bias question again. Did the study look at whether analysts were just finding results that matched what they believed before they started?
Yes, they did address this, which is really interesting. They asked analysts about their beliefs regarding the likely outcome before they ran their analysis, and then asked them again after they got the results.
Okay, pre- and post-analysis beliefs. What was the connection?
They found that the analysts' post-analysis beliefs, what they believed after seeing their own results, were more strongly correlated with the actual empirical estimates they obtained than their pre-analysis beliefs were.
Oh, that's actually quite positive, isn't it?
It really is. It suggests that, on the whole, these analysts weren't just stubbornly sticking to their priors or manipulating results to fit them. They seem to be genuinely updating their beliefs based on the evidence their specific analysis produced.
So more rational updating than confirmation bias or p-hacking, at least on average.
That seems to be the case. The issue isn't necessarily widespread bad faith. The problem is that different analysts making different but defensible choices generated different evidence and then rationally updated their beliefs based on that different evidence.
Leading to 57 different rationally held conclusions from the same starting data. Wow, okay.
It boils down to that inherent elasticity, the unavoidable subjectivity in analysis being the primary driver of the dispersion, more so than strategic manipulation.
So if the problem isn't mainly bad actors, but this fundamental subjectivity, what does this mean for how we trust science, especially business science, using complex data? The standard peer review process for a single paper seems inadequate.
It really does. Peer reviewers might ask for robustness checks, but they usually only see checks around the author's chosen path. They rarely see the results from the radically different, yet still plausible, paths.
So what's the way forward? How do we improve reliability?
This is where the study points towards the broader open science movement and its toolkit. The authors suggest different tools for different problems.
Okay.
To tackle strategic elasticity, the deliberate p-hacking things like pre-registration are key. That's where you publicly declare your hypothesis and analysis plan before you see the data or run the main analysis.
Takes away the temptation to fiddle afterwards.
Exactly. Or using a test holdout sample approach. You do your exploratory analysis on one part of the data, find your potential result, and then you have to confirm it on a separate, untouched holdout part of the data.
Makes sense. What about tackling the inherent subjectivity, the good faith divergence we've been talking about?
For that, we need methods that actually expose the range of possible outcomes. One is multiverse analysis.
Okay.
Yeah, where a single researcher or team intentionally runs their hypothesis test using many, many different defensible analytical specifications, different variable definitions, different models, and then reports the distribution of results, shows how much the finding depends on the choices.
Instead of just reporting the one best result.
Precisely. And the other method is what this study did, the many analysts approach. Get lots of independent teams to analyze the same data and see the collective picture. Both require much greater transparency, like sharing data and code publicly when possible.
So the goal isn't to find the one true analysis, but to see if a finding holds up across many reasonable analyses.
That's the core idea. Meaningful scientific claims are still possible. Our Q2 showed us that. But the claim needs to be robust. It needs to survive exposure to this analytical diversity. You can't just trust one path through that garden.
It really shifts the perspective.
It does. The main takeaway, especially when you're dealing with complex archival data like in business or social science, isn't asking, is this single finding true? It's asking, what's the collective inference? What do we conclude when we map out all the reasonable ways to test this idea? Certainty comes from that convergence.
Which leaves us, and you listening, with a pretty provocative final thought, doesn't it?
I think so.
If establishing real confidence in even one research finding might require multiple independent analyses or these big multiverse efforts, how much critical evaluation should you be doing before you bet your strategy or your understanding on a single published study? The standard for a strong inference, especially from complex data, seems much, much higher than maybe we appreciated.
It suggests we need a bit more humility about certainty derived from any single analysis and a greater appreciation for efforts that embrace and explore the analytical variability.